Yes, so real numbers. So we are talking about number system. We are talking about real numbers. We are talking about rational and irrational numbers. So when we talk about real numbers, we are having two types of real numbers, right? We are having rational numbers and irrational numbers, which you have done in class 9. ये आपने class 9 में भी किया है that real numbers consist of either it will be rational or it's going to be irrational. Now, when we are talking about rational numbers, a number in the form of p by q, where q is not equal to 0, is rational. Okay? Rational numbers are numbers which are basically what? Fractions. So when we talk about rational numbers, always remember that natural numbers, whole numbers, integers, fractions, all this is considered as rational numbers. So rational numbers themselves can be divided into two. One is terminating numbers and the other is non-terminating. Non-terminating, and would anyone like to add to that? It should be non-terminating and anybody knows? Repeating.
No, sir.
Repeating.
Yes, it is non-terminating and repeating. So all rational numbers will either be terminating or it's going to be non-terminating repeating, right? It's going to be terminating or non-terminating repeating. So this is the base of this chapter, that real numbers are either rational or irrational, and rational numbers, yes, Nikhil.
Sir, I want to ask that this chapter is not started in my school.
Yeah. So as I told you, yeah. So that you are coming when you are coming for the offline, you can do the chapters that you are doing. When we are doing online, we will be doing the chapters in order of the textbook.
Okay, ma'am. Okay, sir.
Okay. So that is I had introduced when I introduced the chapter. I told you, since many of you will be doing in different orders, the online class will be doing in order. So that we will have to finish the course that way. If you are coming for the offline classes, then the chapter that you are doing in school, accordingly at your school space, I will be doing those. Okay.
Okay, sir.
Yeah. So simultaneously, you will be able to cover it faster. So you don't worry if something else is going on in the school, that will be covered if you are coming for the offline classes. Otherwise, in the online, I'll be going in this particular order of the textbook. So I'm not asking which school is doing what. I'm just following the order of the textbook. Okay. So this is chapter 1, real numbers. So going further, as I told you, the first part of the chapter is something called Euclid's division lemma. Okay. The first part of the chapter is called Euclid's division lemma. Now, Euclid, anybody knows anything about Euclid? Euclid was a Greek mathematician and he is called as the father of geometry. Okay?
Yes, sir.
Euclid was known as the father of geometry. And last year there was a chapter, Euclid's geometry, but it got deleted because of COVID condition. A lot of course was cut. So Euclid was called the father of geometry. So he gave something called the Euclid's division lemma, and we use the Euclid division lemma to find the HCF of two or more numbers. Whenever we want to find the HCF of numbers, we use this method called the Euclid's division lemma. Right? So yes, the first part of the chapter, I am explaining Euclid division lemma. But before we do the Euclid division lemma, you should know what a lemma and what an algorithm is. So this is the textbook. So if you open your textbook, you will find all this. So I am explaining that one. The first thing that you find on this page, page number 4, is a picture of a person. Now this person is Muhammad ibn Musa al-Khwarizmi. He was a Persian mathematician. Okay, he was a Persian mathematician who wrote a book by the name of Al-Jabr. And that is why this whole topic is coming under algebra. So algebra was derived from the book that he wrote, Algebra. And in fact, the word algorithm is also coming from the name of this person, Al-Khwarizmi. Okay, algorithm. Now, what is algorithm? Algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. जैसे आपने एक steps of construction लिखते हो, you write step 1 this happens, step 2 this happens, step 3 this happens. How to make tea, this is what happens, this is what happens, this is what happens. When you are doing something in steps, that is called algorithm. So the first thing that you write down today is of course the first screen that I showed you. इसको आप लिख लीजिए that real numbers can be rational or irrational. And rational numbers are numbers in the form of p by q where q is not equal to 0. And rational can be divided into terminating and non-terminating repeating. Okay, just note down that. And what is terminating? Any fraction which has an end. आप divide करते हो वो खत्म हो जाता है. So 1 by 2 will become 0.5. ये खत्म हो गया. These are called terminating numbers. And non-terminating repeating, what are those numbers? 1 by 3, 0.33333, ये चलता रहेगा. Number repeat.
So we can put a bar on top.
We can put a bar on top. So that is 0.3 bar. Okay, 0.3 bar. So this is called non-terminating and repeating. So just note down this and then we'll come to the algorithm and the lemma part.
So done.
Done?
Yes, sir.
Okay.
You're done.
So I'm coming back to the page of the textbook here, and now you will write down algorithm. Algorithm, write down, is a series of well-defined steps which gives a procedure for solving a type of problem. So there may be, the problem may be very complex, but when I'm breaking down it into steps, that is called an algorithm, right? So write down this. What is algorithm? Algorithm is a series of well-defined steps which gives a procedure, it's written here, okay, which gives a procedure for solving a type of problem. And once we know what an algorithm is, we will also define what a lemma is, because as I told you, the first topic in this chapter is what is Euclid's division algorithm and what is Euclid's division lemma. So lemma kya hota hai? A lemma is a proven statement used for proving another statement. What is the meaning of this? It's a proven statement. What are proven statements? Like Pythagoras theorem is a proved statement. Now, when you are using those kind of statements which are already proved to prove something else, then that is called a lemma. Okay, so I hope the difference between algorithm and lemma is clear. Algorithm is just a series of well-defined steps to solve a problem. You are telling step number 1, this happens. Step number 2, this happens. Step number 3, this happens. That is algorithm. Whereas a lemma is a proven statement used for proving another statement. Just write down these two. Written down what is algorithm and what is lemma?
Yes, sir. Written.
Okay. For those of you who have not written, this is part of the textbook. You can, if your textbook is open, you can note down from there. Or as I told you, the recording will be available to you. You can always replay and listen to it once more. Okay. So algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. And lemma is a proven statement used for proving another statement. These two things you need to learn. Although in class, up to class 9, you don't learn any theoretical stuff. Now this chapter has a lot of definitions and a lot of theory part, okay? So the first thing that we are going to do today is called the Euclid's division algorithm. Now once we understand what an algorithm is, then we can easily understand what is the meaning of Euclid's division algorithm. So as I told you, there are steps. And if it doesn't have steps, then that is called a lemma. So that is Euclid's division lemma. So Theorem 1.1, we're going to put this heading, Theorem 1.1 as Euclid's division lemma. Okay, that is our first thing, Euclid's division lemma. Now I'm going to read out what is exactly written in the book. So it's little confusing if you read it, but I'm going to simplify it and make you understand what is the meaning of this statement so that it becomes more clear. So if I read this, it's written, given positive integers a and b, there exists unique integers q and r satisfying a equal to bq plus r, where r greater than equal to 0 and less than b. So at the moment, it is all not very clear to some of you. Some of you may have understood, but I'm going to explain this using a simple example. Let's say we have a number 25 and we are dividing this by 3. We are dividing this 25 by 3. Now, how many times does 3 go in 25? 3 goes how many times in 25? Yes? No, how many
Sir, 8
times?
times. 8
3
times.
into 7 plus 3 into 8 plus 1.
Yeah, so 3 8s are 24. That's your first step, right? So
Yes,
you
sir.
whenever,
We
yeah.
get
So this is called the 25 is called the
dividend.
dividend.
The 3
3
is called the
is called
divisor.
the divisor, and q is
And
the
8 is the
quotient,
quotient.
Question.
And 1 is the remainder.
So for every question, whenever we divide one number by the other, we will be able to identify what is dividend, what is divisor, what is quotient, and what is remainder, isn't it? For every question, there will be a dividend, there will be a divisor, there will be a quotient, and there will be a remainder. Now, if you notice carefully, there is a relation which is called the division algorithm. That is, dividend is always equal to divisor multiplied by
Into
the
quotient plus remainder.
plus, correct. The dividend is always equal to divisor into quotient plus remainder. So, इसका मतलब dividend क्या है? 25 is divisor into quotient 3 into 8 plus 1, isn't it? आप divisor और quotient को multiply करेंगे 3 into 8 24 और remainder को add करेंगे तो 3 8 is 24 plus 1 25. Dividend is divisor into quotient plus remainder. आपका जो division algorithm will always be satisfied in all questions. There cannot be a question where this is not applicable. Right? So dividend is divisor into quotient plus remainder. So just note down this. This is the base of the Euclid division lemma. And once we know this, you will be able to understand that definition now. So I'll go back to the definition once you write down this much.
Done, sir.
Done. So once we know that, now let's go back to this question given by Euclid. So क्या बोल रहा है ये? Given positive integers a and b, there exist unique integers q and r satisfying the relation a equal to bq plus r. Now, what is this a equal to bq plus r that he is talking about? He is saying given two positive integers a and b, कोई भी दो नंबर है, जैसे हमने दो नंबर क्या लिया 25 and 3. We were dividing 25 and 3, and he said a, that is dividend. Okay, a is your dividend, is b is your divisor. B is your divisor multiplied by the q is the quotient and r is the remainder. So we are actually discussing the same thing, that dividend is divisor into quotient plus remainder. There's nothing new actually, but he is giving it in a different format. तो कई लोगों को ये समझ में नहीं आता. So Euclid division lemma क्या है? Given positive integers a and b, you can have any two numbers a and b, and then what will happen? You will have a quotient and a remainder satisfying this relationship. What is that relationship? Dividend is equal to divisor into quotient plus remainder. A is equal to BQ plus R. A equal to BQ plus R. This is nothing but the same thing that we did just now. Dividend is divisor into quotient plus remainder. So when I divided this, I got a remainder. Now, I'm asking you a question. Can the remainder be less than 0? Can the remainder be less than 0?
No.
No, sir.
No, sir. No,
No,
sir.
remainder can never be less than 0.
No, sir.
Can the remainder be
The
equal
remainder can be equal to 0 or greater than 0.
Yes, sir.
to? Remainder can be 0
But always
or
smaller than the divisor. Always
Absolutely.
smaller than the divisor.
Yes. So remainder जो होता है, the minimum value is 0, right? You cannot have a negative number. You will have minimum value as 0. And what will be the greatest value? It will be always greater than or less than the divisor. तो ये जो statement है, next वाला, R is greater than equal to 0, less than B. What was B? B was the divisor. 3 से कम होगा. Can the remainder
Yes,
here be
sir.
3? Can the remainder be 3? No.
No, it can be 2. Last is 2.
It can be 0, 1 or 2. ठीक है, so हमेशा ये याद रख लेना कि जो रिमाइंडर होता है वो डिवाइजर से कम होगा. It cannot be equal to the divisor. So this is the meaning of this r greater than equal to 0 less than b. So I hope you have understood this, that dividend is divisor into quotient plus remainder, and the remainder will always be greater than equal to 0 and less than b. So now you can note down this, because they can ask you what is Euclid's division lemma. तो आपको ये लिखना पड़ेगा. And now I think it is little more clear to you that what is the whole lemma about. So you can write down this Euclid's division lemma heading. Given positive integers a and b, given positive integers a and b, there exists unique integers q and r satisfying a equal to bq plus r is greater than equal to 0 and less than b. ठीक है, समझ में आ गया होगा अब तो कि क्या है ये a is bq plus r, and why do we write r greater than equal to 0 and less than b. As I told you, in case somebody is not understanding, please feel free to ask.
Sir, please explain one more time.
Okay, the remainder part or the first part? The first part was when I am dividing a number by the other, this is dividend, this is divisor, this is quotient, and this is remainder. Have you understood this? Or no?
Yes, sir.
Yeah. So the relationship was that dividend is always equal to, when I multiply the divisor and quotient and add the remainder, 3 8s are 24, 24 plus 1, 25. 24 plus 1, 25. तो हमारे पास क्या आ गया? एक relationship आ गया. Dividend is divisor into quotient plus remainder. And I told you that this is the same as A is BQ plus R. A dividend है, B divisor है, Q quotient है, और R remainder है.
Okay, sir.
Okay, and the remainder cannot be negative. Remainder can be minimum 0, but it has to be less than the divisor. That's why we write r greater than equal to 0 and less than b. So ये लिख लीजिए, given positive integers a and b, there exists unique integers q and r satisfying a is bq plus r greater than equal to 0 less than b. Done?
Yes, sir.
Yes, sir.
Okay. So now,
Yes,
once we
sir.
know Euclid's division lemma, I am in a position to solve the question that is given in exercise 1.1. Exercise 1.1 में आपको first question दिख रहा है, using Euclid division algorithm find the HCF. तो जो हमने अभी Euclid division lemma किया, we break it down into steps, then that is called algorithm, because we defined algorithm as what? Algorithm is when you are taking
A series of well-defined steps.
a series of well-defined steps. Absolutely right. So when I'm going to take a question and I'm going to create a series of well-defined steps, then that becomes my division algorithm. So here, the first question is find out the HCF of 135 and 225 using Euclid's division lemma. Okay, that's 1.1 question number 1, first part. So what am I going to do? This is my A and this is my B. Always remember the bigger number will always be A. बड़ा number हमेशा A होता है, छोटा number B होता है. Dividend is always greater than the divisor when we are finding out
Divisor.
this. So here we will divide the bigger by the smaller.
So long division method.
Yeah. So normal method of division, 225 को आपने 135 से divide करना है. So we know that 135 ones are 135. 135 into 2 will give me 270. So वो नहीं हो सकता. I'll have to take the smaller one. So first step क्या आ गया? 135 ones are 135. You will subtract. You will get a remainder of 90. Okay. I'm dividing normal division. I'm just dividing this. I'm getting this. Now, what are we supposed to do? We will write here according to Euclid's division lemma, A equal to BQ plus R. R is greater than equal to 0 less than B. So, हर question में ये आपको mandatorily लिखना है. You have to write this question in every question that you are attempting. According to Euclid's division lemma, A equal to BQ plus R is greater than equal to 0, less than B, always. So now they are asking us to do by Euclid's division algorithm. So we need to write this in steps. So step 1 kya hoga? What is your A? A is your dividend. So that becomes 225. Okay, is equal to divisor, that's 135, into quotient is 1 and remainder is 90. Have you understood the first step? Dividend is divisor into quotient plus remainder. So 225 is 135 into 1 plus 90. So ये हो गया आपका step 1. Now how do we find the HCF? Now Euclid said that if the HCF is 0, then stop. अभी 0 नहीं हुआ. If the HCF is not 0, then your previous divisor will become the new dividend. ये जो पहले आपने divisor लिखा 135, that is going to be your new dividend. तो आपको ये 135 यहाँ लिखना है. Okay? 90 आया, 0 तो नहीं आया ना, 0 आया तो बंद करना है. अगर 0 नहीं आया तो
Yes, sir.
previous divisor will become the new dividend. So 90 will go how many times in 135?
1. It will give 45 as the remainder.
92s are 180 होता है, तो 90 ones are 90. I'm going to subtract this. I'm going to get 45. अभी भी remainder 0 नहीं आया, तो again previous divisor will become the new dividend. तो previous divisor कितना था?
90. So 90 will become the new dividend.
The 90 will become the new dividend. 45 goes how many times in 90?
Twice. 45 twos are.
45 twos and 90, we get 0, we stop. And the last divisor that we get when the remainder is 0 is your HCF. So 45 आएगा आपका answer. HCF of 135 and 225 is 45. So this was our step 1. 225 is 135 into 1 plus 90. Now step 2. Step 2 क्या है? Dividend क्या है? 135. Divisor क्या है? 90. Quotient क्या है? 1. Remainder is 45. Step number 3 is 90 is your dividend now, 45 is your divisor, quotient is 2, remainder is 0. Now once we get 0, we stop and we say the last divisor where the remainder is 0 is your answer. So answer will be HCF of 135 and 225 is 45. Got the method?
Yes, sir.
Divide the bigger by the smaller. See what is the remainder. If the remainder is 0, stop. If the remainder is not 0, take the previous divisor and make it the dividend. Continue the process till the remainder comes 0, and the last divisor where the remainder is 0 becomes your HCF. So you can note down this, and those who have done this can try the next one, 196 and 38220. Find out the HCF of 196 and 38220. You can note down this, and in case somebody has not understood any step, please ask. I hope all the steps are clear, because these steps, whenever the question is Euclid's division lemma or Euclid division algorithm, it is used to find HCF. Okay, so HCF जब निकालेंगे तब होगा.
Okay, sir.
So again, when I'm doing with 196 and 38220, 196 and 38220, what am I going to do? I'm going to divide the bigger number by the smaller number. Okay, so this becomes A and this person becomes B. This person, the bigger number 38220 has to be divided by 196. So your first line will remain same. And what is that first line? This one. ये हमेशा हर क्वेश्चन में लिखेंगे according to Euclid division lemma, A equal to BQ plus R greater than equal to 0, less than B.
Sir,
Yes.
Sir, HCF is 196.
Yes, that's right. So those who have not been able to do, 38220 has to be divided by 196. Who gave me that answer just now? Somebody gave me that answer. Who was that?
Sir, me.
Me, matlab?
Sir, Mahua.
Ah, okay. Okay. Yes, you are right. So 38220 divided by 196.
It will go 1 times.
So 196, ones are 196. Kyunki 196 into 2 isse bada hoga, so I am not going to take that. It's going to be 392. So ye 382 hai, 196, 190. So I'll subtract this, I'll get 6. This is...
Sir, 196.
No, already 1 has gone. No, so yahan pe 7, yahan pe 8 aega na?
Sir, 1862, I meant, sorry.
Yeah, 186.
My
Yeah.
bad.
Then we'll subtract, we get 186. Bring down 2. Now I have to see 196 goes how many times here? So 196 into
Sir, 9 times.
is a 54.
1764.
9 is 81 plus 5, 86. And 1764. I'm getting 1764. So this is going to be 8. This is 9 and 00. So I'm bringing down 0. Now 196 will be multiplied by which number to get 980? Let me try 5 times. 6 5 is 30. 9 5 is 45 plus 3 48. 5 1 is 5 5 9. So I'm getting 5 times. And so I'm getting 0. So if I'm getting 0, I'm going to stop. Yes.
तो आपने 2 नहीं लाया दूसरा सर 3 8 एक तो 2 ले आए सर दूसरा 2 नहीं लाया आपने
Huh?
सर आपने 2 ले आया पर दूसरा 2 नहीं लाया
डिवीजन जब करते हैं तो एक एक नंबर ही तो लाते हैं नीचे.
यस सर सर तो एक नंबर को डिवाइड करने के बाद सर दूसरा 2 भी तो आएगा फिर
382 लिया है ना हमने 196 1 से 196 तो ये 186 आ गया तो फिर 2
ओके सर आ गया सर यस सर
हाँ
यस आ गया सर
Shaurya, you are from which school?
सर
Huh?
लक्ष्मण पब्लिक स्कूल
Okay. Yeah. You had come that day, no? For the first orientation class? Or no?
सर आया था
हाँ?
सर आया था
ना? ठीक है. Okay. Yeah. So here अभी जो है कहाँ तक पहुंचे? Yeah. So here I'm going to break this into steps. और यहाँ पे हमने ज्यादा steps नहीं किए. ये we realize that this 38220 is directly divisible by 196. हमने आगे कुछ करना ही नहीं है because this is a perfectly divisible number. So A equal to BQ plus R, when I am doing this, I will get 38220 is equal to 196 into 195 plus remainder is 0. एक ही step में आ गया. आगे करने की जरूरत ही नहीं है. We don't have to do it further. The reason being we've got in the first step itself, it's perfectly divisible. Earlier we had 2 steps and 3 steps. Why? Because the remainder was not coming 0. So right now we have got in 1 step. So HCF will be my divisor. So HCF will be 196. Next is 867 and 255. Those who have done this will try 867 and 255. 867 and 255. You can try out this and find out the HCF of 867 and 255. So this becomes A and this becomes B, right? And you're going to divide the bigger number by the smaller number. 867 by 255.
So 51.
Okay, so 255 will go 5 times. How many times? No, sorry. 255 will go 3 times.
So 51 is the answer.
Yeah, 51 is the answer. That's right. So 255 into 3 is 765. I'm going to subtract this. I'll get 2, 0, 1. 102 are remainder is not 0. If the remainder is not 0, the previous divisor will become the dividend. So यहाँ पे 255 आपको लिखना है. You have to write 255 here. 102 will go how many times in 255? 2
Sir,
times. 2 will go, I will get 10 into 2, 204. I'm going to get 51. And once I get 51, again, remainder is not 0. So the previous divisor will become the new dividend. So 51 into 2, 102. So I'm going to get the remainder 0 and I will stop. So here, I have got in 3 steps. This was step number 1. Of course, first I will write, according to Euclid division lemma, A is BQ plus R greater than 0, greater than equal to 0, less than B. 867 is 255 multiplied by 3 plus remainder 102. Second step, this was step 1. Step 2, we've got 255 is 102 into 2 plus 51. And step number 3, we got 102 is equal to 51 into 2 plus 0. So we've got 0, so we are going to stop there. So the HCF will be 51. The last divisor becomes your answer. So HCF क्या आया इसका? HCF will become 51. So with this question, we have completed the first part, that is how to find out HCF by Euclid division lemma. Now remember that we can find out HCF only by Euclid division lemma. You cannot find out LCM. HCF and LCM अगर दोनों आता है, then we will use by another method which is called fundamental theorem of arithmetic, which I will be discussing in the next class. So right now I have discussed only one method to find HCF, and that is by Euclid's division lemma. Everyone has finished?
Yes, sir.
Yes, sir.
Yes, sir.
So we come back to the second question. Show that any positive odd integer is in the form of 62 plus 1, 62 plus 3, or 62 plus 5. Again, question based on Euclid division lemma. So I will say A is equal to BQ plus R according to, okay, this is every question you have to write this, according to Euclid's division lemma, A equal to BQ plus R. Now in
B
this,
will be 6.
yeah, in this question, the coefficient of Q is 6. So we will say let value of B is 6. Now, if you go through some solved examples, you will get different values. जैसे आप ये solved example आप देखोगे, here it is 2Q and 2Q plus 1. See here, 2Q, 2Q plus 1. In example 3, you will find 4Q and 4Q plus 3. In every question, it may not be same. They're all different values. So in this particular question, the value that is besides Q is 6. So that is why we are saying let B equal to 6. So what will happen? A will become 6Q plus R, and R will be greater than equal to 0 and less than 6. Why? Because we know that according to Euclid's lemma, R greater than 0 and less than B होता है, और B हमने क्या लिया? 6. So R will be greater than equal to 0 and less than 6. So R values will be 0, 1, 2, 3, 4, 5. 5. It cannot be 6, right? Because it is less than 6. Now these are the values that you have to substitute. So A will become 6Q. A will become 6Q plus 1. I am putting different values of R. A is 6Q plus 2. A is 6Q plus 3. A is 6Q plus 4. And A is 6Q plus 5. Out of which this is even, isn't it? Every multiple of 6 is even. This is odd. This becomes even.
Is even.
This is odd. This is even. And this is odd. So question was of the odd numbers. So I have got 3 odd numbers. Which are the 3 odd numbers? 6Q plus 1, 6Q plus 3, and 6Q plus 5. जो हमें prove करना था.